things. So we've got this idea of parallel lines. I think we know what that is. Skew lines may be something new. Skew lines. So lines that intersect are coplanar. Lines that do not intersect, right? So parallel lines don't intersect, is that right? Parallel lines? They are coplanar. Think about that. Can you think of any set of parallel lines that are not going to be in the same plane? And again, can I find 3 non-collinear points for any set of parallel lines? Sure. So when we have parallel lines, just so you know how to mark a diagram, if you're given lines in some kind of diagram, you cannot assume them parallel unless you see this kind of marker. That's kind of our little universal symbol of they're parallel. Some books will use something slightly different. Maybe they'll fill them in. But as far as when we're drawing diagrams, just putting this little marker here means we've got some parallel lines. We use this parallel symbol. So 2 lines that move parallel to say lines are parallel. So this says over here that M is parallel to N, just notation. Okay, now skew lines, that may be new. Has anybody heard of skew lines before? Skew lines don't intersect, but they're not necessarily parallel. This is kind of that, you've got one line here, you've got one line here in space, and they're not coplanar. So before we even do that, I'm just thinking about this idea of not being coplanar. Did anybody watch Star Trek movies? Star Wars? Anybody see those movies? Yeah, somebody must have seen those. Yeah, and you know, oh, here comes the, what do they call the thing, the Klingon ships? The warbird, what do they call them? Oh, come on, you don't know the Klingon ships? Really? Oh my gosh, they're like the warbird or the warbird. There's got some name for them that I don't know. And then you've got the Starship Enterprise. You ever watch them meet in the movies? Now we're in space, right? They're always on the same plane. Up is up and down is down. You know, when you think about space travel, how come one isn't like over here and one isn't here? Why aren't they more like skew planes? So I've always wondered that, and I guess the makers of these movies have not thought about what space is really like. Anyway, never mind. Okay, so let's see. In this figure here, can we name lines that intersect? So I've got 2 planes, and this is a set of lines. Are these 2 lines, M and N, are they parallel? How do I know? I've got the little markers, so I know they're parallel. So lines that intersect. What are some lines that intersect? Yeah.
Line K intersects
Line K. And line what? N. So we can see them here. We see that point of intersection. How about some lines that are parallel? Parallel, yeah.
line M and line N.
Right? M and N, because they have the little markers. Now we have lines that are skew, right? They're not necessarily parallel. They're not parallel. Yeah.
Line K and line M.
Line K and line M. So look at this one's going this way. This one's going this way. Will they ever intersect? Are they parallel? Are they coplanar? No. So our skew lines are K and M. How about planes that are parallel? This one's a little bit trickier. You have to know a little something about parallel lines, which is what we're learning today. They actually are parallel planes, T and U, because it's showing me some angle congruence. We're going to learn a little bit more about those angles and how you can tell if lines or planes are parallel. So we do, but maybe that wasn't a fair question at this point. Okay, so here we go. Think of each segment in the figure as part of a line. So I've got this cube figure. I guess I don't know if it's a cube with all the sides equal yet. But they're showing me the right angles. So they're at a minimum, the faces are rectangles. What do we want to find? Can we find lines parallel to CD that contain point A? Yeah, Michelle.
Line AB.
AB. How come? And here's point A. Because we see these 2 figures here, I know it's a rectangle. The opposite sides here are going to be parallel. How about, can we find lines skew to CD? Yeah. AH. So let's see if we can picture them. So here's my CD, and here's AH. Are they ever going to meet in space? Now, it's like, you know, look at them dancing here. One arm goes here, one arm goes up. Are they ever going to meet? They're not going to meet. That's what a skew line is. Can I make a plane out of them? can't. Yeah.
What about line AG?
What about line AG? Is that another one? What do you think, guys? If I've got CD and I've got AG, are those skew lines as well? Yeah? Think we have any others? Has to go through A, right? So what other lines do we have? AB is parallel, so it's not a skew line. You can make a plane. And that one intersects. So I think we found them. Nice. How about any lines perpendicular to CD that contain point A? Yeah. We got another one. Where? Which one? AE. Oh, looks like we go this way. Yeah, what do you think? Is that going to work? I think it's, yeah, what do you think? AF. AE, AF. So if we're going outside of our planes, we can find some more. AF. Yeah. AG? No, didn't do AG. Good. All right. How about some perpendicular lines that contain A? So we're perpendicular to CD. Yeah. DA. Because that's going here, right? So how many others with A? Do I? Well, I need point A. I need point A. I don't see any. Huh. How about planes parallel to plane EFG? So which one is EFG? That's my bottom one, right? I want to see if there's any planes parallel to EFG containing point A. Yes? Which one? ADE? ADB. Okay, right, this one. So we got the bottom half. This top half should work as well. Okay? Now, if you're having trouble seeing this, because sometimes there are people who just, they can't see 3D. And it's not like there's anything terrible going on. Sometimes just, that doesn't develop until you're a little bit older. For some people. If you're not quite seeing it yet, just be patient with it. You got to get used to it a little bit. All right, now let's see. So parallel and perpendicular lines. So we've got some rules here. If two lines are in the same plane, then they're either same plane now, right? Parallel, perpendicular, or intersect at a point. So we agree. Think about that. You've got two lines. So what are your possibilities? Two lines. Well, they might be parallel. Right? We agree. I think. What else can happen with two lines? They could intersect. Could they do anything else with two lines in a plane? Yeah. I'm in a plane now. Now, when I think about what skew is, can you draw skew lines in a plane, especially when the definition of skew is that they're not coplanar? So, skew lines are very much a 3D kind of situation, where otherwise they're going to touch during the plane. So I can't really have that. Can anything else happen with two lines? Can they intersect at an infinite number of points? Now we talked a little bit about this in algebra. We have one line on top of another. Then we have that with all real numbers. Remember, like, you could have all the points intersecting. In geometry, we're thinking of this as the same line. We're thinking of one line. So I guess you could think of that as infinite number of lines. We're thinking of it as one. So I don't have two lines. So this case doesn't really apply. So let's see if we can come up with the rule. For a point, not on a line, how many lines can there be? So here's a line, here's a point. How many lines can I draw through that point? How many? I can draw an infinite number, right? Or can we answer this question? How many of them is going to be parallel to this line? One. Exactly. So there is only one line you can, even though there's an infinite number of lines you can create, only one of them will be parallel. And this is part of our parallel postulate. If there is a line and a point, not on a line, then there's exactly one line through the point parallel to the given line. Parallel postulate. Postulate means I can't prove it, right? You know what that means? I can't prove this. Now this is Euclid's fifth postulate. He wrote a book, Euclid's Elements. He had a lot of trouble with this one. He felt this is one that we should be able to prove, and it kind of upset him a little bit. So I went and I looked up Euclid's fifth postulates, and I thought it was kind of interesting that if we used Euclid's Elements as one of our textbooks, this would be something you have to kind of read and understand. If a straight line crossing two straight lines makes the interior angles on the same side less than two right angles, the two straight lines, if extended indefinitely, meet on that side on which are the angles less than the two right angles. So I at least have a picture, right? So here's two lines where this is less than 90 degrees. So it's trying to say if they're less than 90 degrees, you're going to get some kind of intersection here. It was a different mathematician who kind of rewrote this postulate in a way that we can more readily understand. John Plater was a mathematician, a scientist, lots of things, philosopher. He lived, I want to say late 18th century into the early 19th century. I don't think he actually invented this, but he made it famous. Here's another way to say Euclid's fifth postulate. The one that looks kind of obvious. It works really well in Euclidean geometry. If you're looking at non-Euclidean geometry, which is we're not just looking at flat planes. Maybe you have some curved space, which is more like what we believe the universe to be, right? Oh, ask Einstein, right? Our universe is probably curved. This doesn't hold up so much anymore. But for our purposes, we are going to look at a nice Euclidean flat plane. We're going to go with that. Just so that I see a little history about what this class could be if we were using the elements book. Okay, here's the perpendicular postulate. Let's see if this makes sense. If there is a line and a point not on a line, then there's exactly one line through the point perpendicular. That makes sense, right? Because think there's an infinite number of points that can fit through P. So they're going to curve. They're not going to be at exactly 90 degrees except for that one line that works. Excellent. Okay. So we're just going to keep those little rules in mind as we start talking about transversals. A transversal is a line that intersects two or more coplanar lines at different points. And I do have, let's see, I hope this is working today. Sometimes it works, sometimes it doesn't. So here we have, they're showing parallel lines. But this is the idea of a transversal. So it crosses two lines, and I think I don't even have to make them parallel. So they don't have to be parallel lines, but the transversal is crossing them. And I could have a third line, a fourth line, as long as they're all coplanar, I can have a transversal that runs through it. We have some words that we use. So if you kind of think of it a little bit like railroad tracks, the two lines that are being crossed. Now get this. If you're inside the railroad tracks, we say you are interior angles. Inside interior. If you are outside the railroad tracks, we call you exterior angles. And by the angles, I'm talking about these angles that are formed when that transversal crosses. Alternate angles are on either side of the transversal. So here's an angle on one side, an alternate angle would be on the other side. A consecutive angle is on the same side. So these are all consecutive angles. These are consecutive angles. But this and this, those are alternate angles. You will sometimes see same side used instead of the word consecutive, but they're on the same side. Right? So just different terminology for how we label these angles. Let's see what we got here. Corresponding angles. Yes?
Little alternate angles, I think vertical angles.
It can be, but you can have an alternate. Look at number 2 and number 5. Those are alternate angles too. The 4 and 5 are alternate angles. 4 and 7, 3 and 8. So yes, 1 and 4 are alternating angles and are vertical, but you can have other ones as well. Yeah?
1 and 2 alternate angles.
1 and 2, I guess they are. According to this definition, they're on either side of transversal. I guess they are. So now corresponding angles. So what we're basically doing is we're labeling names for the angles so we can identify them more readily. Corresponding angles are in the same position of the two lines. So what does that mean? So again, here's my line. This one's my transversal. This one is in the upper right of the its line. The transversal's on the left. If you think of these as positions, he's over here. Look at where the position of 6 is. It's also kind of upper right. So they're corresponding if they correspond to the same location. These are corresponding angles. We also have alternate interior. So if we understand alternate means that we're on different sides of the transversal, alternate interior to be on the inside. So this one and this one are alternate interior angles. I could make another set of alternate interior angles. Where would they go? Yeah, where would they be? Yeah, I don't have any numbers here. I'm just going to put some numbers in here. I think of alternate interior angles. To me, it makes it easier if I can make a Z. Yeah, I'm making a little Z here. It's these angles. And your Z can be backwards. So if I make a little Z going this way, Z backwards, these ones are my alternate interior. So the Z can be backwards. Alternate interior. I just find it easier to find them. Yes? By definition, these are alternate interiors. Have to be like the little caps on a Z. And you found them. Okay. Now alternate exterior. Let's see if we can figure that out. Right? They're going to be on either side of the transversal, but they have to be on the outside. So 1 and 8. I have another set of alternate exterior. I call this one 2, call that one 3. That's another set. My little Z doesn't work quite as well. But we just alternate exterior. We're outside the two lines. So we're the exterior and we're alternating around the two, around the transversal there. Other kinds of lines that we have, consecutive interior. Sometimes these are called same side interior. I've seen it both ways. And how does that work? You have to be in the interior. So now I'm inside the two railroad tracks on the same side. So I've got another set, 1 and 2. This is another set of consecutive interior. There is such a thing as consecutive exterior as well. Can you guess what consecutive exterior is? Yeah, what do you think? Right? So we have those as well. I don't know why we don't have to like write that one down. I don't know. But they're the same kind of thing. All right, so those are our definitions. So let's just look over here. And I've got an example of two lines and a transversal. Can we name pairs of angles that are corresponding angles? And again, you may have to look at your definition. What does corresponding mean? What does it mean to be a corresponding angle? Can anybody find two angles that are corresponding angles? Yes, sir. Angle 2 and angle 6. Are there others? Are there other corresponding angles? Angle 1 and angle 5. Right here and here. In that same spot. Yes? Which one? 3 and 7. Angle 3, angle 7. Because they're in the same bottom left, bottom left. Yeah. Angle 4 and angle 8. Same spot, bottom right. So as long as you're in kind of that same location, you're corresponding. How about interior angles? Interior angles. What are the interior angles here? Remember, I'm inside my railroad tracks. What are they going to be? Yeah. So everything inside the railroad tracks. These are all interior angles. How about alternate interior? Alternate interior. Yes, sir. 4. Yeah, angle 4 and angle 5. Alternate interior. I've got another set. What else? Yeah? 3 and 6. Angle 3 and angle 6. And again, I look for my little Z. So I know these match. I've got a Z going backwards. Those match. How about consecutive in, whoops, where is this? Consecutive interior. Consecutive or same side interior. Same way to say it. Yeah, what do we get? 4 and 6. Do we have any others? Yeah. Angle 3 and angle 5. Okay. Exterior angles. Exterior angles. Nathan, name me some exterior angles. Exterior. 1 and 7. Yeah, all those guys on the outside of the railroad tracks. Alternate exterior. Alternate exterior angles. Okay. Now, they have to be exterior, so they have to be outside the railroad tracks. And then they they have to be ones that alternate around. Try again. So pick one of the exterior angles, right? These are my exteriors. This one, this one, this one, or this one, this one. So pick one. One and they both have to be exterior angles that alternate around the transversal. Which one? 1, 3. Well, 3 is inside the rear arc guys. Right? See these guys here? This is inside. Everything inside here. This is outside. So when I'm talking about exterior angles, I only want outside angles that alternate around the transversal. So if we're starting with 1, what's its alternate exterior angle? 8, exactly. Alternate exterior. How about another set? There is another set. Yep. 2 and 7, this one and this one. They're on the outside, and they're alternating around the transversal. Vertical angles. So how many vertical angles? Yeah. Excellent. Angle 1 and angle 4. So what else? Yes. Angle 2 and angle 3. What else? Yes, sir? Angle 5 and angle 8. Any others? Yeah? Yep. Angle 7, angle 6. So we know our vertical angles is where you have the lines that intersect, the opposite angles there. Supplementaries. Do I see any supplementary angles? Yeah, which ones do you see? No, 1 and 2. How come they're supplementary? They're a linear pair postulate, right? Yeah, one. Good. Where else? They're all over the place. Where else do you see one? Which one? Yeah, 7 and 8. These are supplementary. Any others? Yeah. 1 and 3. Absolutely. 2 and 4. Where else? 5 and 6. They're everywhere. Right, we didn't even get them all. I don't know if we got this one, we did this one, this one. There's lots of supplementary angles. So lots of places where they're going to add up to 180. So lots of different relationships. All right, so I have to know all these different angle names? Yes. Yes, you do. Okay. Let's classify these angles. What kind of angles are those? Yes. Corresponding, how do you know? Yeah, so this is, how come we have a word here? Oh, I'll make my things here. Went through that trouble. Yeah, because this is top left, top left. What is that going to be? Wow. Wow, what's that going to be? Alternate exterior, right? This is my inside. They're both on the outside, so they're exterior angles. They're alternating around that transversal. Alternate exterior. What about these guys right here? What are those things? What are those things? Alternate interior. Because now I'm on the inside, so I know they're interior angles, and they're alternating around that transversal. Yeah. It's not so bad. You do have to know all these names, but if you remember what it means to be inside, what it means to be outside, what it means to alternate, they're not too bad. I think they're not too bad. Let's see what you guys think. Okay, now we kind of get back to what if we make those two lines that cross, what if we make them parallel lines? So I've got my little markers here, so I know that these two lines are parallel. And I've got my line C, which is my transversal, and I've labeled my different angles that are formed here. So interior angles that lie inside the parallel lines, I've got my little dots here, right? Those are interior angles. My exterior angles, these are the ones that lie outside, so it's the same rules. I've also got my alternate interior angles. They're inside, that makes them interior, and they alternate around. What would be another set of alternate interiors? Yes, sir? 3 and 5. Okay. Alternate exterior angles are on opposite sides of the transversal and outside the parallel line. So again, outside, that's the exterior, alternating around this transversal, and then corresponding angles are in the same location on the other line. So we kind of fill in all the different ones that we have. We've got lots of different kinds of lines and angles that we have to keep track of. But as long as we think about what the names are, they almost tell you where they go. Pretty much. Now, what about these angles? When you have parallel lines, special things happen. So let's see if this will work. I'm going to try this. What I did was I created kind of a little shape that fits into the angle 1 position. And so what if I create another shape? And let me see where it might fit. Oh, wait. Are those two lines, do they appear to be congruent? Those two angles, do they appear to be congruent? What kind of angles are those? What's their name? Corresponding. So what can I conclude, at least inductively, about corresponding angles? They're congruent. They appear to be congruent. Let's see if I have any others. Now, I know something about vertical lines already. Let's see if I can get this to kind of work here. So I know vertical angles are congruent. That one we have proven. So we see that, right? So what else is congruent then? What else is congruent? That one. Well, before we even get to ones we haven't looked at yet, you're right. But just from the picture, what can I tell? Yeah, these two are alternate interiors. Are they congruent? Yeah. Yes. Yes, what a great observation. Yes. The lines must be parallel. If you're looking at the other ones, and we can look at some of the other examples, like, they're not congruent. Because look, this one, we could say, let's pretend that's perpendicular, and this one isn't. They're not going to be congruent. So that's an excellent observation. They must be parallel for these things that we're discovering here to be true. Great observation. Asa is right though. He did say, well, what about angle 7? So let's see what happens with angle 7 here. Right? Well, I know it has to be congruent to this one here because of the vertical angle. So now what am I seeing here? What kind of angles are congruent in a situation where transversal crosses parallel lines? Yeah. Alternate exterior. Look at that. What else did we discover? Corresponding. Alternate interior. Wow. All right, now my little green space, that's supposed to fit in here. Let's see if it fits in here. Okay, so I'm finding kind of the same thing here. Right, there's corresponding angles. Let's turn this guy around. See if I can get him in here. Okay, so have I kind of covered all the angles that are formed? Am I still seeing those alternate exterior angles? Now, how about the ones, the adjacent angles? Are they congruent necessarily? My yellow and my green. They don't have to be. When would they be congruent? When would they be congruent? Yeah, when you have a nice perpendicular transversal. But if they're not, what do I know, though, about these two? What do I know? They're supplementary because you're a linear pair, and linear pairs are supplementary angles, right? You have the linear pair postulate. So I've got a choice here. Pick any two angles in this situation. They are either what? Congruent or supplementary. Those are my two choices when they're parallel lines. So let's see what we've got here. Angles are supplementary or they're congruent. That's my only choices. What are the congruence rules? As we know, we've proven this already, that vertical angles are congruent. Corresponding angles are congruent. Alternate interior angles are congruent. Alternate exterior angles are congruent. Now we haven't really proven any of this, have we? I'm using inductive reasoning, aren't I? Aren't I? Because it works for this one, it must be true for all of them. That's where I'm going right now. What about supplementary rules? Who's supplementary? Now we can see like this one, this one, this one, this one. What about my consecutive interior angles? Now which ones are those? Like this and this. Isn't that consecutive interior? So what can I conclude about those angles? Now are they congruent? No, but what are they? Supplementary. Supplementary. What about consecutive exterior? Remember what those are? A same side, but on the outside. What can I conclude about those? Supplementary. So consecutive interior as well as exterior, we can say that. Other angle pairs are secondary. So that's our choices. So we can find a lot of information without, only being given one small piece of information. So just to go through the theorems and postulates that we have. So the corresponding angle postulate. So do we have to prove that one? Postulate? Remember, the postulates are one that I don't know how to prove it. We're just going to make that assumption. Two parallel lines are cut by a transversal. And again, trying to elect Sam's point here. They do have to be parallel. Then the pairs of corresponding angles are congruent. Now we're going to start working with theorems. Would you mind showing me the theorems? Thank you. The alternate interior angles theorem, if two parallel lines are cut by a transversal, in parallel, then the pairs of alternate interior angles are congruent. This one's a theorem. We're going to have to prove it. Alternate exterior angles theorem, if two parallel lines cut by a transversal, alternate exterior angles are congruent. And consecutive interior. Two parallel lines cut by a transversal, the pairs of consecutive interior angles, and remember, I like same side as a better word because I think it describes it a little bit clearer. Those same side interior angles are supplementary. So I don't have to prove my postulate here because we're just going on that assumption, but let's see if we can prove alternate interior angles. So the alternate interior angles theorem says if you have parallel lines, alternate interior angles are congruent. So I'm given parallel lines. That's really all I'm told. And I want to prove angle 1 congruent to angle 2. Isn't that what I'm trying to prove here? So, yeah, I can put these on your paper, but just let's think about this. So P is parallel to Q because we're given parallel lines. That's our if, our conditional there, our hypothesis. Angle 1 is congruent to angle 3. So we doctored up our diagram. Why is 1 and 3, why are they congruent? Why is that? They're corresponding angles. We have a postulate for that. We're going to assume that's true. I will say this. I usually don't write this. I write this. Corresponding angles of parallel lines are congruent. I was taught that you kind of do write out the theorem for the ones that you can. It's much clearer. This is not necessarily like a global name that everybody approves of. So I'll accept either. Now I'm saying angle 3 is congruent to angle 2. Why is that? What? Well, yeah, it's right there, but do you even need to see the reason? Why are these two congruent? Yeah. Yeah, vertical angles are congruent. And I'm just writing, this is how I write proofs. That's fine if you write that. But I like writing out the reason because vertical angles are congruent. We've proven that already. It's a theorem. So now how do I go from these two statements to this statement? This one equals that, right? A equals B, B equals C. So I can use the transitive theorem of congruence. We proved this. It's the theorem. It's okay if you're a property. The congruence is the important part. You can't say it's the transitive property of equality. Why not? Test takers, why not? Yeah, this is congruence. A property of equality does not apply to this situation. So there were a number of little mistakes like that on the test. You only use theorems that apply to what you're doing here. So great. So now this is a theorem we can use. We've proven it. So now we know deductively that alternate interior angles of parallel lines are congruent. So let's look at the exterior angles. So I'm given the same thing. I've got my two parallel lines. I want to prove 1 and 2. Because those are alternate exterior angles, I want to prove them congruent. So what do I know? I'm given that they're parallel lines. 1 congruent to 3. So why is 1 congruent to 3? Okay. They're corresponding angles. Corresponding angles of parallel lines are congruent. Now I'm saying 2 congruent to 3. Why? Yeah. Vertical angles are congruent. And now what? Well, it looks like I've got some transitivity here. Angle 1 is congruent to angle 2. My alternate exterior angle. So it's the same kind of proof. But now I'm using stuff. This is useful now. We were just proving things for practice before. Now I've got useful stuff I can use. And the last one, consecutive interior angle theorem. So again, I'm given that N and P are parallel lines. Why are 1 this statement. 1 congruent to 3. Why? Yeah, luckily, I proved this first. Alternate interior angles are parallel lines are congruent. We've proven that. I can use that now. So 2 and 3 are supplementary. Well, how do I know that? 2 and 3 are supplementary. Yeah. Yeah, and you know what? I don't even think this is the right reason. I think it's more the linear pair postulate. They are a linear pair, but if they are a linear pair, then they are supplementary. That's the linear pair postulate. So that's probably a better reason here. So why are 1 and 2 supplementary? Because that's what we're trying to figure out. And I just used some substitution here, saying because 1 is congruent to 3, then I can replace 3 with the 1. And that is, substitution, that's probably not a good reason. It should be transitive theorem of congruence. I'm going to change my mind there because I'm working with congruent angles. But, great. So now we can use these things. Isn't that awesome? Yes. So now, where are we? We're on the back page here. We want to find the value of x. Oh. I've given a little tiny hint on the diagram. How am I going to do that? Because we don't have a name for this and this, right? But is there a relationship that we can figure out between that exterior angle and that interior angle? What do you think?
The parallel
Well, let's see. Like this angle is an exterior, this is an interior. Do I have any theorems that talk directly to those two angles? We know about alternate exterior. I know about alternate interior. I know about consecutive interior. I know about corresponding. Do I have one for this situation? So what else can we do? Now, I like where you're going, though. What else do I know, though? So let's see. I've got a little hint on here. You see this one? Why is this one marked for us, do you think? It's okay. He's got it. Why do you think this one's marked? What do I know about these two? How come? They're vertical angles, so I can do that. Now do I have a theorem or postulate that works with same side interior or consecutive interior angle? You can look, you can look. Do I have anything for consecutive interior angles? Consecutive, right? Consecutive means same side. Alternate would be other sides. Consecutive interior. Keep looking, it's there. Go. Look, page 2. I'm not letting go. Is there anything about consecutive interior? They're supplementary. So what can I do now? Supplementary means they add up to 180. So what could I write? Yeah? Plus? There you go. Right? So this is the thinking we got to do. Sometimes you have to chase those angles around a little bit to find the theorem or postulate that we have. Nice job. I didn't mean to put you on the spot. You did a good job there. So let's see what we got here. 120, right? This is where you got to watch me carefully. This is where I make most of my mistakes. Looking for something that should be easy. X equals 60. Did I get that right? Okay. Now, again, this is where you have to read the questions carefully. It said find x, so I'm done. Sometimes it says find the measure of the angle. So read those questions carefully. Don't just stop after you solve the equation. Yes?
So if we had to find every angle and then give us one.
Yeah. Can we do that?
Find everything.
You think so? Let's see if we can do that here. Can I find all the angles? Well, what else is going to be 115? No, everything's on 115. The corresponding. What else? The alternate exterior. Do we have any other 115s? What's the other angle going to be? Why 65? Well, these are supplementary. Supplementary. Vertical angles. I can find different reasons. So that means this whole thing must have been 65. So all I need is one angle. I can absolutely find all the rest. You could have approached it that way. I'm just going to label them all. And now I can see that x plus 5 equals 65, so x is 60. Yeah. Vertical angles do not have to be supplementary. Okay? And just look at this example here. 65 and 65, you're getting 180. They don't. You can think of schemas too, right? You can right? They don't have to be, unless they are what? When would vertical angles be supplementary? When you have perpendicular ones. Okay, excellent. Good questions, you guys. All right, this is kind of going along with what Asa observed. I'm only giving you one angle. And I'm asking for 4, 5, and 8. Yes. They're wide. Yeah, and like, there's a number of different reasons I can say. I can say, well, these are because they're vertical. These are because they're corresponding. Maybe I'm going that way. And then these are vertical. So I can get there without even mentioning alternate exterior. Or, these are alternate exterior. So you can go about them in a number of different ways to get there. What's the other angles, by the way? 2, 3, 6, 6, and 7. What are they going to be? Yep. 75, right? So we can easily find all the different angles we need to find. What else we got here? Oh, good. I love a real life example. Your toothbrush holder. Finally, we can get to the bottom of this. Ever wonder what's going on with your toothbrush holder? We don't even have a toothbrush holder. We just put it on the side of the sink. Well, let's pretend you're in a fancy house. And you have this fancy equipment in your bathroom. Anybody have something this fancy? No, I know. Who can have something this nice? But anyway, so what's going on here? I got my lines here. It's not telling me they're parallel, but I'm guessing they want this to be parallel. You think about building a structure, unless it's built badly, you know, if they make this crooked, there's not going to be a very good structure to it. So we're going to work with the assumption that they're parallel. Now, each question is different. They don't depend on each other. So if angle 4 is 65 here, it's not necessarily 64 here. They're completely different questions. So, in one universe, the angle 4 is 65 degrees. What is the measure of angle 1? Yes, because of vertical angles. All right, let's look at the next universe. In this universe, the measure of angle 7 is 110 degrees. So what's the measure of angle 2? Yes? 110 degrees. Why? Why? Connor, why? What kind of angles?
Alternate exterior.
Alternate exterior angles. Nice. Let's see. What universe am I living in now? Angle 3 is 117. Leela, what is the measure of angle 5? Now let's see. Angle 5. Oh, we got same side interiors. Yeah, so now we got to do that subtraction. What are we going to get? Well, tell me how first. Right? They're supplementary. Right? Oh, am I on the wrong? Oh, maybe I am in the wrong place. Could be me. Oh, it is me. You're right, I'm wrong. Okay, let's see. I want 5 and 4. What happened? Let's pretend it didn't happen. All right, I believe they're going to come back. I'm back. We're doing this one now. We're doing the measure of angle 5 is 71. And Galila's going to help me and tell me what the measure of angle 4 is. 5 is 71. What's 4? I've totally messed you up. I'm sorry. Why? Because they're alternate interior angles. I know the girl knows it. That was completely my fault. My brain just went on vacation for a couple of days. It's halfway done. Now I'm on this one. 3 is 117. And now we want 5. Now I've had time to work on it, right? So if 3 is 117, what's 5? 63 because why? Yeah, we're on the same side. Consecutive interior angles are supplementary. 1